In almost every kitchen on Earth sits a steel box designed to contain high-energy electromagnetic radiation. This machine blasts food with invisible waves that vibrate water molecules so violently they generate their own heat. This process is known as dielectric heating, and its discovery was an accident. In 1945, engineer Percy Spencer noticed a candy bar in his pocket had completely melted while he was standing near an active radar set. The energy that melted that chocolate came from a cavity magnetron, the core component developed to power short-wavelength radar systems during the Second World War. By 1947, Spencer's employer, Raytheon, had patented the technology and released the first commercial microwave, the radar range. As a piece of repurposed military hardware, it was massive, standing over 5 feet tall. Every modern microwave sitting on a kitchen counter is a miniaturized, safely contained version of that same military radiation chamber. To understand how this machine cooks, we have to look past the casing and treat the interior as a strict pipeline of energy conversion. The electrical current travels a direct, linear path, from the wall socket, into the high-voltage transformer, through the magnetron, down a metal waveguide, and finally into the main cooking chamber. Understanding this technology requires following a single burst of electricity along this physical journey, observing how it is shaped and amplified at every step. The journey begins at the wall socket. Standard alternating current enters the appliance and feeds directly into a high-voltage transformer, which steps the voltage up to lethal levels. This component acts as a self-regulating system using magnetic leakage flux. If a power surge occurs, the transformer's magnetic core saturates, automatically dropping the output voltage and stabilizing the current before it damages the machine. That stabilized high-voltage current then enters the cavity magnetron, the core generator of the system. Inside the magnetron's vacuum tube, the intense voltage strikes a central filament made of tungsten and thorium. The heat boils electrons off the metal, while a strong magnetic field forces those escaping particles into a tight, swirling vortex. The magnets bend the paths of these orbiting electrons, so they constantly brush past the narrow openings of precisely carved copper cavities. The effect is identical to blowing air over a half-filled glass bottle to make it whistle. These cavities resonate with electromagnetic energy, generating a wave that oscillates 2.45 billion times per second. This swirling electron cloud is the literal engine, converting raw electrical power into the precise microwaves required to cook food. The newly formed electromagnetic wave is channeled out of the magnetron, funneled down a short metal tube called a waveguide, and released into the cooking chamber. This chamber operates as a Faraday cage. The electric fields of the microwaves interact so strongly with the free electrons in the metal walls that the waves cannot penetrate the steel. Instead, they bounce off the interior surfaces. Even the glass door is lined with a conductive mesh. The perforations in this mesh are fractions of an inch wide. Because the microwave has a wavelength of 12.2 centimeters, it is physically too large to pass through the holes, while the much smaller wavelengths of visible light escape easily. Trapped inside the chamber, the waves pass into the food, targeting polar molecules. Water molecules, for example, have a positive charge at one end and a negative charge at the other. As the alternating electric field washes over the food, it forces these polar molecules to rapidly flip back and forth, continually trying to align themselves with the shifting wave. This creates immense molecular friction, which we feel as heat. This chart shows the dielectric constant for microwaves at various temperatures. Fats and oils absorb energy less efficiently than water, but have a lower specific heat capacity and a higher vaporization point, reaching temperatures far higher than boiling water. Smooth, flat metal walls reflect these waves safely, but placing a sharp metal object, like a fork, inside the chamber disrupts the entire system. The oscillation of the microwaves concentrates a massive electric field at the sharp corners of the metal. This intense field strips electrons from the surrounding air, ionizing it and creating bright sparks of electrical discharge. The microwave oven does not project heat directly. It induces violent mechanical friction at the molecular level, forcing the food to heat itself. Bouncing microwaves creates a three-dimensional standing wave, locking into a fixed pattern of high-energy peaks and zero-energy valleys. If an object remains static, sections in the peaks incinerate, while valleys freeze. The turntable solves this by dragging food through these spots, ensuring even exposure. Newer inverter microwaves deliver continuous, lower-intensity waves using pulse width modulation, preventing the outer edges of the food from overcooking. Evenly heating a meal depends on the precise movement of physical matter through the rigid geometry of an invisible wave. Because this radiation is completely contained, interrupting the process is instantaneous. Releasing the door latch cuts the electrical power to the magnetron entirely, immediately stopping wave generation. The moment the power is cut, the electromagnetic field inside the chamber decays in a matter of microseconds. By the time the door swings open, there is zero residual radiation left inside. Despite the persistent consumer myth, microwaves do not cook food from the inside out. Microwaves generally only penetrate the outer inch of an object. The center of a thick meal only cooks because that superheated outer layer transfers its thermal energy inward through standard physical conduction. Today, the process is so streamlined that the complex physics happening behind the glass are completely hidden. We set a timer on a mundane appliance entirely divorced from the high-voltage transformers and vacuum tubes running inside. The microwave oven is a masterclass in human ingenuity, safely harnessing the invisible forces of the electromagnetic spectrum simply to heat our dinner.